Dear students, today we will learn to clip irregular shapes. Let's take this example where we have a rectangular clipping window depicted in purple color and irregular shapes depicted in this color. So now when you have to clip irregular shapes which have no mathematical notation like equation etc., in such a case we will enclose these irregular shapes into a bounding rectangle in this way. So bounding rectangle is the smallest rectangle that covers whole of the shape inside it. It can be drawn very easily. For this window, minimum value of x-axis, x-min is the leftmost point, and similarly we have x-max as the rightmost points, y-min as the topmost, and y-max as the bottom boundary. So this way we can bound them in the smallest bounding rectangle. Every shape is bounded in this rectangle. So now these bounding rectangles, these irregular shapes will be identified by the bounding rectangles. So now for example, this shape is covered in this boundary. So this shape will be represented by x-min and y-min of this rectangle and x-max and y-max of this rectangle. Similarly, we can do with all the shapes included in the clipping window. And further, the clipping rectangle boundary is depicted as the xw min, yw min and xw max, yw max as usual. Now each of the bounding rectangle can be worked out against this clipping window. We can have three different cases. In this case, the complete rectangle means it's this extreme point as well as this extreme point. Both the extreme points are outside the window. This you can check very easily as we had done it in the point clipping. This is the first category. In this case, the rectangle is completely outside the window. Bounding rectangle is completely outside the clipping window. Similarly, the second case is this. In this case, both the extreme points of the bounding rectangle are within the clipping window. So therefore, second case is the irregular shape is completely inside the window. Obviously, in this case, in which the bounding rectangle is completely outside, you will reject it as such, and in this case you will accept it as such. But the third case, in which the bounding rectangle clashes with the clipping window, means one extreme point of the bounding rectangle is outside the window and the second extreme point of the bounding rectangle is inside the window. So in such cases we have to do some work. So this window will be this shape will be rejected outrightly and this window will be accepted as such. So after clipping we will have something like this. So the work which we do on this, the window which is clashing with the clipping window, we have to divide it into four parts like this. So now the same procedure is reversed with these four rectangles. For example, this rectangle defined by this and this extreme points will be completely outside. Similarly, this rectangle will be completely outside the clipping window, but these two sub-rectangles will be clashing with the window. So therefore we will reject them summarily and work on it like this. So now our shape is reduced to this much now. So we will again divide this rectangle into 4 sub-rectangles like this, and we will take up the case one by one. This rectangle depicted by this and this extreme points is completely outside. Similarly, this rectangle is also completely outside, so they will be rejected as they are, and these two rectangles have clash with the window boundary. So after rejecting these two, we are left with this. Now we will let's apply the same procedure on this rectangle. Divide it into 4, and after that these two sub rectangles are completely outside, so they will be rejected as such. These will be worked out. So now let's repeat the procedure with this sub rectangle. Divide it into 4, and after this these two rectangles are completely outside and these two rectangles are completely inside, so these two are to be accepted as such. So after a lot of divisions of rectangles, you will reach a point where a sub rectangle is either completely inside or completely outside. So here at this point we will stop. We will now shift our focus to this rectangle, so we will repeat the same procedure with it. Then after getting the rectangles only either outside or inside, we will shift our focus to this rectangle and we will do it recursively. So after doing so, we get the line clipped in this way. So after removing these boundaries, we have this figure as the final clipped window. So similarly, this